Welcome to the Transducer and Instrumentation Virtual Lab. Now we are going towards the experiment number 3, that is study of AC and DC bridges. So in order to start the experiment, there is a run button. You have to go to this run button in order to start the experiment. So I click this run button. Now I am ready to do the experiment. Now I'm just ready to do the experiment. This is the off button for starting your experiment, for ending your experiment. Here you can select the different images of the components which have been used here, the real images of those components. As resistor, you can see the resistors are here, inductor, the different types of inductor are here, capacitor, voltmeter, and a battery. So in this way we learn that what exactly and how exactly those components look like in the real, and how exactly all the components have been used in the circuit diagrams in the building of the circuitry of the different bridges. Now we are going to start. As I click this on button, now the image here changes. Another circuit diagram, it shows that 4 different resistors, different branches. Now this is for the calibrating R3. Now for the calibration of R3, you have to fix the other 3 resistors, and you have to just move this R3, that is the resistance at the branch 3. Now similarly for the R1 also, you have to just move the jockey on the resistor R1. It is a variable resistor, so you have to just move the jockey on the resistor R1, a variable resistor R1, and you have to keep fix these other 3 resistors. Now as I am do the experiment, suppose I make it to suppose this did. Suppose I choose this to be as my other 3 resistors, that is R3, R2, R4. Now I have to move this resistors all over this region, so that I should get the balanced position where the bridge exactly is being balanced. So in order, the place where the resistance, that value of the resistor will make that bridge to be in the balanced condition. Balanced condition means the voltage across the voltmeter becomes 0. Now you have to select what voltage input you want to give. As I select this voltage input, suppose I select to somewhat like 4.17. Now again I will move this resistor a whole of the area, and I will see that at 2 this bridge is becoming balanced, because at this position the voltage output is becoming 0. Rest all other position we will see that now some voltage is there, it's not becoming exactly 0. So we say that at 2 the bridge is becoming balanced. So this we calibrate the value of the resistor R1, that 2 ohm is the resistance required so that the bridge could be in the balanced position. Now similarly is for the calibrating R2 also same process, and we have to again select the different values, and now we have to just move this resistor in whole of this area, and we will see that at a particular resistor we are getting a balanced condition, as if we are getting 3, as the 3 ohm is the value of that resistor and the branch R2, which will make the bridge to be in the balanced state. And see, as if we are moving this, we see that pointer is also moving. Now similarly for the calibration R3, we again have to fix the 3 resistors, and again we just move this R3, and correspond that we will again get a voltage output here. This meter will indicate the voltage output, and this is the numeric indicator of the same voltage output. Similarly for the calibrating R4 also, you have to fix again the 3 resistors, and now we can change so that we can get a different value, so that we can get the value where exactly the bridge is becoming balanced. So this was the whole story of the Wheatstone bridge and how we have to exactly perform the experiment using Wheatstone bridge. Now we're going towards the Carey-Foster bridge. Now this is the Carey-Foster bridge in which R1, R3 and R2 and R4, these are the 4 resistors. You have to fix them at any value, and now you have to just slide the jockey, and as you are changing you will see that the jockey is moving to the whole of the wire, a wire whose per centimeter of resistance is 2 ohm. So first of all you have to select some input voltage. As you will select the input voltage, and now when you will change this, and suppose if you are changing, you keep it fixed like anything, you will get a voltage output here. You have to wait some time. Actually it took some time, and it will be showing the output voltage here. So in this we understand the Wheatstone bridge, how exactly it works it out. You have to set the different resistors value, you have to fix the resistor value, and again you have to change the slider, you have to slide the jockey on the wire so that you can have a, so the purpose of using Carey-Foster bridge is to select a wide range of resistance rather to take a small value of the resistor. We can have a wide range of resistance so that we can put the bridge to be in a balanced state, and that resistor or that calibration can be done. So now we will move towards the AC bridge. Now this is the first part of the AC bridge, that is Maxwell bridge. Here for the input we have to just make this is the capacitor C1 which is been here, and again we have to select some value for the R1. For the R2 we have to select some value. Now as you will select some value, you will see that value of inductance, that is the unknown inductance value here, and the unknown resistor value. As you will change the value, the different value, you will be seeing that it will take some time. Actually it has to calculate as per the different bridges, so it may take some time, as it is mentioned here that at least wait for that time so that the process get complete. Now, as I will change this value here, you will see there will be a change in value. It will take some time. So see, now the Rx is being changed to 0.86. Now similarly for the, so in this way on changing C1 value and the R1 value, R2 and R3 value, we saw that there is a change in the unknown inductance value and the resistance value. So suppose if I will change this, so you will again get some value change here. Now again you will see that there is a change in these values. Yes, you will see that it changes from itself from 0.3 to 0.48, and that is also in Henry as the unit of the inductance. Now similarly we can go for the Wien's bridge. As you will select the Wien's bridge, you will see that there will be a change in the, see, this is the circuit diagram of the Wien's bridge. Now here again we have to choose some value. For your section you will see that the unknown frequency, this is the unknown frequency voltage source. So as you will choose value of the C3 and C1, you will see that there is a change in frequency. As I am changing it, it will get some value in frequency, and that frequency will also shown through this diagram or through this graph. You can calculate also. So in this way we understand how the Wien's bridge and calculating the unknown frequency of the voltage source. Now this is the Hayes bridge. where R2, R3 and capacitor are the input value, and the output value is the inductance, which is the unknown value inductance. So as I will, we can fix these resistor value to some point as a fix to some 2.5 and to make it to approx 4. Now if we will move this, we will see that there is some change in the capacitor value. This is the meter indicator of this capacitor C4, and as per your action you will see that there will be a change in the inductance value, and this is the meter indication of the inductance value, and this is the capsule indication of the. So in this way we get the value of the unknown inductance, and unit is also here, that is Henry. Now for the D shorty brace, you can again, you have got input, you choose R3, R4 and the capacitor. As you change the value of the capacitor, you will see that there will be a change, and you will be getting a certain value of output of capacitor C2. You will see that this is a tank is being filled, and the value of the capacitor C2 is 0.077 ohm. That is 0.077 farad. Now in this way you see that different input, as you will input the different values of R3 and R4, you will get the different values of capacitor C2. Now as I will change my bridge to steering bridge, now you have your input side is containing R2 as R2, R3, C2. This is R1, R2 and R3 are the resistor values, and the C2 and C3 are the capacitor values. Now as I set the different R2 and some value for the R3, and as I will change this capacitor C2 and this C3, you will see the corresponding to your change you will be getting this R1 and this C1. The process may took some time, as I have told you earlier that it has to calculate, so it may took some time. Now as per you will change your C2 and C3, you will see that different values you are getting for the different values of C2 and C3. You can fix your value for R2 and R3, but you have to make variable for your C2 and C3 so that you can get the different values of your R1 and C1. Now again, if I'll change this, you will see again 4.3. This way we understand exactly how the bridge works and what is exactly the circuit diagram of the different bridges. Once you're over with your experiment, there is an off button. You have to put your experiment to be off. Now as you will click the off button, here again you will see the real images of the components which are used in the circuit diagram. So in this way you understand how exactly these bridges works and what circuit diagram and how the outputs have been calculated. Different outputs have been calculated through different bridges. Bridges have got a wide number of applications in the industries, in the system building. Different bridges have got different applications. So in the conclusion, I think that you have understood a lot more concept of the bridges. If you don't understand each and every bridges have got this procedure here, you can go through this procedure and you can do the experiment as many number of times as you want. So in this way, many facts for the bridges are being cleared. And now you can go through the experiment, you can work on it. Thank you.